Hi, I'm Bjorn Trias, and I'm here to demonstrate the user interface of one of my process control apps that I have available for free on the App Store. The app is currently running on an iPad Pro 12.9 inches, but I also tested it on a smaller device. The strip charts don't come out necessarily quite the same way, but the application still runs okay. The process in this app is a distillation column separating methanol from water. It's somewhat strange in the sense that I'm mixing methanol and water together into a feed stream and let the column separate that feed stream into pure methanol and water. I'll do that so that you can actually test both feed rate disturbances and feed composition disturbances. This column is highly automated with a number of feedback controllers, as you can see on the piping and instrumentation diagram to the right. On the left-hand side, you can see the corresponding faceplates to these controllers. One of the more important controllers in the system is the tray temperature controller. It is, as a default, set up to control the temperature on tray 3, and it controls it at 92 degrees. The output from this tray temperature controller goes to another controller in a cascade mode, and that controller is the Vapor FC. The Vapor FC controls the amount of vapor that goes up in the column by adjusting the amount of steam that goes into the reboiler. The tray temperature controller can also be in a cascade mode from yet another controller, the bottoms composition controller, that controls the amount of methanol in the bottoms water stream. In order to get that to be in cascade mode, you would have to press the cascade button on this controller. I'll show that in the demonstration. You see the Vapor FC already has its button for cascade mode pressed. So let's now switch over to the simulation itself. The first step is to remove the piping and instrumentation diagram by pressing the back button here. And behind it, we see a couple of charts. Those are profile charts, and they really show compositions and temperature in the column as a function of the position, the tray number. I can get other charts with this system, and one of the ways of doing that is to press the charts button, and I'm going to do that, for example, on the tray temperature controller. If you do that, you get the present value or process value and the output for the controller side by side, which is very convenient in testing the control system. I can also get other charts one by pressing the little plus button up at the top, and there I see a whole range of controllers. So let me pick the methanol profile chart. So now I have 5 charts here, and those can be moved around if I wish. For example, I can grab the methanol profile chart and I can place it right next to the temperature profile chart. I can also get rid of charts. Let me get rid of, for example, the McCabe field diagram. I press the Edit button, I press on the McCabe field diagram, I press the trash can, and then I'm done. I press done. And now I have the 4 charts that I'm going to be interested in for the continuation here. The tray temperature controller is currently in automatic mode, and I can change the set point by typing in a new number in the set point field. But before I do that, I'd like to illustrate the neat feature of the profile charts. I'm going to double tap on the curve itself, and it turns red. I'll do the same on the methanol profile. The red line is now superimposed on the blue line, but the red line is the reference line, and as I make changes, I'll see the blue line start changing. So I get a comparison where the profile used to be and where it is when I make changes. So let me now put in a value of 98 degrees for the tray temperature controller and see what happens. Immediately, I see how the profiles are starting to change, and of course I see the control tray temperature moving up to 98 degrees while making a fairly minor adjustment to the vapor flow controller and its set point. As I made this move, you see that the bottoms composition controller went out from spec. So it's only 150 parts per million of methanol in the water, whereas I got in the distillate, I got several thousand parts per million relative to the set point. So let me now demonstrate how the cascade system works between the bottoms composition controller and the tray temperature controller. I simply press the cascade button on the tray temperature controller, and the bottoms composition controller will start adjusting the set point to the tray temperature. This takes a little while, so I'm going to be quiet and let this run so I can speed it up in the video. Okay, I'm back narrating here. I think this is as far as I'm going to take it. At this point, I'm going to switch the tray temperature controller back into automatic, and I'm going to set its set point to 92 degrees and let the system line out there. I'm now going to show you how to tune these controllers. The first thing I want to do is to take a look at the settings that I could do for each controller. So by pressing, the tune button on the tray temperature controller, I see a number of items here. So let me go through those fairly quickly. First one is the name, of course, and then the three items here that pertain to a PI and D controller. So the first one is the gain, second one is the reset time, and the third one is the derivative time. The next entry has to do with the action of the controller. In this case, it's reverse acting, and if you press the button, you'll make it direct acting, but this controller is supposed to be reverse acting, so that's where it is now. Then I have the zero and the maximum for the transmitter. The difference between the two is, of course, the span of the transmitter, in this case 150 degrees. Then there's another field where I can enter a value if I have an analyzer or some sort of delay in my measurement system. I have this set for 90 seconds, 0.025 hours, and that's to compensate for the thermocouple delay and the transmitter delay. I can set output limits to the controller. It's currently not limited, so it can go all the way down to 0 and to 1, which is the maximum. The next two fields I'm going to discuss shortly, so I'm going to skip over and talk about the ramp. You can ramp this controller up to an end set point that you set in that field, and you decide how long time you're going to be ramping this. Okay, so let's go back to the controller itself now. It's pretty much lined out at 92 degrees. So now I'm going to press the ATV button. And the ATV button starts generating an output signal that you can see on the Vapor FC set point. You see that's starting to go up and down. And that's being generated by a piece of software in the controller that puts the process into a state of oscillation. And these oscillations can be read off by the controller and deciphered to see what the period of oscillation is and what the amplitude of the control temperature is. So let me go back into the tray TC by pressing the tune button, and now you see I've gotten two values in the gain from ATV and the reset time from ATV. They differ a little bit from the gain and reset time that I have, but they provide very good starting points for tuning. So I could take those new values and put them into the gain and reset time fields if I want to, or I can make some adjustments, or I can make the system test a little bit more, and let's see if those values changed. They're pretty much the same. So that's what the test came out with this time. Okay, I think this is pretty much what I can show for the controllers themselves. There are a couple of other things that you can do with the simulation. You can certainly pause it by pressing the pause button. You can start it again. You also have the ability to configure it. So the current feed tray location is at 6 and the control tray temperature location is 3. You can change those values if you want to control at a different location or feed at a different location. You can also, as I mentioned earlier, you can change the feed flow and you can change the feed composition. You can do that in terms of a sine wave to check out disturbances of various kinds and see how the control system responds to those. Okay, that was a pretty extensive review of the interface, and this is going to be useful for future videos and future apps because they use the same system.